Hello, everyone. Tony here, and today I'm gonna do something a little bit different. With all the doom and gloom that we see around social media and YouTube and the news, I wanted to instead bring you guys a message of hope. This is a what I believe is gonna be the bright future for all mankind, and something that should hopefully refresh your hopes in our near future, near and distant future. Okay. So here we see Mars, okay, and it's ironic, right? We're thinking about the future of mankind in a place that's desolate and has no life and no atmosphere and is very remote, okay. But the reason is Mars is our closest planet, right? And Mars has a secret that is very reassuring. Mars has polar ice caps. There is water in Mars, and there's probably also ice underneath the surface of Mars. Right now, we can see these are all missions that have been sent to Mars to survey. Look how there's a satellite that just passed through the polar ice. They're scanning, they're analyzing, they're getting a lot of information because there is an idea, a mission to terraform Mars. What that means is to turn Mars into an Earth-like planet. Okay, uh, so here's a picture of the polar ice caps. There's plenty of ice and there's more water underneath. But in order to terraform Mars, what they're gonna do is melt the ice caps so that they create liquid water, and then that will allow plants to flourish and be able to grow naturally in the soil of Mars, because the atmosphere of Mars is mostly CO2, carbon dioxide, which is what plants absorb from the atmosphere, and then they release oxygen. Okay, so with just being able to melt the ice caps, they'll be able to totally transform Mars. There is it's a lot more complicated than that. Definitely, surely, there's brilliant scientists working on this, and I'm not one of them. But it's plausible. It's very possible to achieve this. To turn Mars into an Earth-like planet. Okay, and that's brilliant. That's brilliant because that means our near planet can also sustain human life. We can move, and it's not because we're gonna destroy our planet. Okay, and we need somewhere to evacuate. Okay, it's not a life raft. Okay, we only have one Earth. So we have to protect it, and we are protecting it. But we need to get to Mars. We need to get to Mars, and because there's imagine Mars, being able to get to Mars means that we can also get to other planets farther away. For example, the moons of Jupiter. There is also ice. There are glacial moons around Jupiter, Saturn, and other planets. But we need to get there first. And there's so many resources throughout our solar system that we can start harvesting. For example, in the depths of Saturn, the pressure is so low that carbon gets compressed into diamonds. So imagine if we could just build a hypothetical net that captures the diamonds, okay, and brings that up to the surface, and we're able to create drills from that. That means that we don't have to no longer extract diamonds from the earth, from our planet earth. So the idea is to extract all the resources that humanity needs to flourish, grow, expand, but harvest them from planets that are remote, that are lifeless, that there's not going to be any consequence to ecosystems. There are no ecosystems, all right? It's just rock, and there's no even atmosphere, okay? So if we're able to replace our drills on Earth with drills throughout the universe, we can stop consuming our natural resources, okay? And we can return to a planet that is clean. There is no you know accidents from oil spills or nuclear disasters, and there's more. Okay, I touched on the nuclear because that's very important, right? Right now, in order to reach those far reaches of space, it'll take months, years of travel. Okay, space travel, and an astronaut locked up tight in a spaceship for years at a time is very difficult. So we need to find a way to uh, get there quicker, okay? And in order to do that, we probably have to propel ourselves to near light speeds to achieve a distance of travel, a time of arrival that's feasible for a human life to travel back and forth, so that we can send resources to colonies in the far reaches of our solar system, for example. Right now, most spaceships use solar powered sails. Okay, they gather energy from the sun, and then they use that to create small sustainable um, projection. Right, they turn that energy into momentum. They into it's through propellers or whatever technology is equipped, but that is not enough. That's not abundant enough or powerful enough to reach those near light speeds that we need. Okay, so what is the scientific community trying to do? They're trying to achieve fission. Fission is the opposite. Well, I see it as the opposite. A scientist can correct me on that, but as fusion. I mean, uh, yeah, I said it backwards. Okay, they're trying to achieve fusion, okay, which is the opposite of fission. Fission is what we see in nuclear reactors, where they create a chain reaction where they split a complex molecule or an atom, and then into small pieces. So the idea is to split that atom and release a lot of energy. That energy is then captured, and in most nuclear reactors, it heats up water and then boils and turns really large power turbines, which then turns into electrical energy. Okay, but that's very, very volatile. It leaves the residue, the nuclear residue, all right, and at the same time it's not that efficient. It's not as efficient because we're not directly harnessing that nuclear explosion, right? We're we're moving windmills and then capturing electricity. But fusion, on the other hand, is kind of like the wow. It's an amazing concept. And fusion, just to give you a reference, fusion is what happens in the core of the our sun, or any star for that matter. It happens when the mass of the sun is so large that it creates an incredible amount of pressure inside the core of that star that causes two very low, uh, what's the term, scientific term, basic atoms like hydrogen, helium, okay, atoms that have um, very few protons, neutrons, and electrons, okay, very base atoms, hydrogen particularly in the sun, to condense into more complex atoms. Okay, they start fusing together, and in that process of two atoms coming together, as we can see in this diagram, a lot of energy is released, and that is the same energy that then pushes outwards from that core, from the star's core, and creates this a constant cycle of energy. That's the pressure pushing in, fusing more atoms, and then the energy release that's pushing outwards, creating a balance in a star where constantly hydrogen is being consumed and transformed into energy. And that's the energy that reaches us as sunlight, as radiation sunlight that's released from that fusion process that happens in the core. So scientists are trying to achieve that same process, but in a controlled environment, like they did with fission, with the separating of the molecule, the nuclear reaction, right? What we call the nuclear reaction. Okay, so um, fusion, the benefit is that since you're not splitting anything and releasing electrons into the environment, random electrons into the environment, there's no radioactive waste or fallout. Okay, not fallout. Fallout is not the word, but radioactive waste, a radioactive material that's the residue of this reaction. In fusion, you take two hydrogen and then they come together to create a inert an inert molecule, okay, which is that arrangement, but nothing is released, okay, nothing besides the energy, nothing, no electrons are left, which is that radioactive energy that we see that causes all that damage if not contained within the reactor, okay. So fusion is a very clean energy and it's extremely efficient. Okay, it's an extremely efficient energy that will uh, allow us to reach safely, because since it's not volatile as well, we can put it in a spaceship. Okay, and it would be relatively safe. I'm not sure how that's gonna work. That's up to the future to define, but it's feasible. Okay, it's feasible. It's not putting a nuclear reactor inside a spaceship. That's gonna be a big no-no. Okay, when you see Star Trek spaceships, okay, they are running with fusion cores. Okay, they're fusion reactors. They already proposed, the idea that these interstellar spaceships can carry with them uh, fusion reactors. Okay, but what are we going to use for fuel? Okay, in the first Apollo missions, okay, I believe it was Apollo 11, found with their samples that they took from the moon, they found that the moon was rich in helium-3. It's a very rare type of um, isotope, okay, that doesn't exist on the Earth. But it exists abundantly in the moon. The thing is that helium-3 is what scientists are considering for using as the fuel for fusion reactors. They're gonna merge molecules of helium-3 together to create the fusion and process. Okay, this is their most promising research. So that's why they're racing. All the countries right now are trying, or all, let me just not just say countries. Let me say all the space programs are racing to get to the moon so that they can claim the helium-3 deposits. Okay, um, so why? So the other thing is about fusion is that compact fusion reactor is plausible. It's very plausible. There's a lot of brilliant engineers that are working on micro fusion reactor. Okay, a reactor that puts these molecules together, it creates the fusion process, but it's small enough to fit a truck. Okay, it fit on a truck, and it will provide energy, that small device, to power 100,000 people. But think about a interstellar spaceship like a freighter that has multiple fusion cores, fusion reactors, and they generate so much power that they can propel. They can install massive propellers. Okay, or not propellers. What's the uh, just oof. Okay, let me think. Well, let me show you. I'll show you an example of a starship. But before, let me just mention the main benefits of fusion fusion reactor. This is an example of a fusion plant. There are a lot of places on Earth, scientists that are working on building right now. There's a lot of um, experiments going on, but these experiments are actually building concepts that, and they're trying to achieve fusion here on Earth right now. But it would be abundant energy. It would just take hydrogen and helium to in order to create this amount of energy. It's sustainable, so you can keep using it without running out of the resource, right? Like for example, fossil fuels are not sustainable because we're gonna run out of them, or and also they're ruining our environment. There is no CO2 emissions like or any other harmful greenhouse gases. There's no emissions other than the inert residue, which is what is set next. There's no long-lived radioactive waste. So imagine in space, you don't have to be managing radioactive waste if you have a nuclear fusion reactor in your spaceship. Okay, there's a limited risk for proliferation. What this means is that I was just gonna say fusion doesn't employ fissile materials like uranium and plutonium, so it cannot be exploited to make nuclear weapons. Okay, so they cannot take the technology of fusion to make nuclear weapons or weapons of mass destruction. Okay, it's just pure energy that's going to be released, but not in a way that apparently can create nuclear weapons. Okay, there are no risks of meltdown like we sadly saw in Fukushima yeah, a few years ago, and apparently the cost is gonna be efficient because we'll be able to make so much energy in that scale of a technology. In a small reactor, relatively small reactor, we're gonna generate so much energy. It's gonna be so efficient. It's gonna be incredibly efficient. Okay, so I want to show you a concept of this. This is a Starship concept from SpaceX, and what you can see here is the what I call the propellants, but there probably are propellants, but I think of propellants as windmill propellants, like an air, but like jet streams that make the spaceship project forward, right? So if this spaceship contains a nuclear fission, I mean a fusion reactor, then it can possibly sustain all this energy, propelling it forward without need of fossil fuels. Okay, we wouldn't need a volatile, massive tank of fuel in order to reach the farther reaches of space. All right, and so what I want to show you is the that that is where we're heading. Okay, so we're heading towards interstellar civilization, okay, interplanetary civilization. We still haven't left our star, which is interstellar, sorry, but interplanetary species where we'll be able to efficiently travel from planet to planet, from moons to moons, okay, with near light speeds in a starship that's no bigger than this one. Like you saw, no bigger than a truck. So imagine that you have parked a spaceship with a fusion reactor, a small compact fusion reactor in your driveway, right? And you're able to go out to space and reach incredible speeds and reach the farther reaches of the solar system in I don't know, relatively short amount of time compared to years or months that it would take, because those speeds are achievable with this kind of energy, with kind of this so it's gonna be a very small solar system, kind of like imagine before airplanes, how big the world felt. Just our planet, the Earth planet, it probably felt huge. You had to take one ship, one sail, which was powered by wind sails, and it took weeks at least to reach one continent to another. It took a lot of time, and they were very dangerous treks through the ocean and everything. Now we just get on a plane and we're in the other side of the world in a few hours. Okay, not even a day's time. So I think what's about to happen. very near, very near. There are plans to arrive in Mars in 2035, I believe. If you can correct me the year, but within a decade or two, okay, not very far. And they've been saying that the fusion core reactor is always 10 years away. But they've been saying that for a while, so don't expect it to be near. But there are a lot of experiments already undergoing, and I believe we're close. We're close, especially once we reach the moon and we're able to extract helium-3. Okay, that's gonna be revolutionary. And imagine all, like, we'll be able to bring energy to all parts of civilization on here on Earth. We'll be able to build fusion reactors that will be able to power humanity, and there's not gonna be a energy crisis anymore. We're about to we're so close to solving the energy crisis in the world. Okay, but we still need to get there. We still sadly need to still extract fossil fuels, extract steel, if I mean iron, and make it into steel, and create the spaceship, extract gold, because we have to protect our spacemen, okay, and women, right, from radiation. In space there is no atmosphere, so the sun's radiation will just go through a spaceship if it's not coated in gold or other um, types of similar materials. That's why you see that the space helmet is gold plated, so that when they're out in space, they can reflect that the whole suit is covered with, so that they can protect that. Okay, but now we see a glimpse of the bright future that's ahead of us. Okay, it's so close. We have to just stay on track and put all our efforts to get there ASAP, so that we can stop drilling on Earth, stop extracting fossil fuels, and literally clean our environment, because also we won't have any fusion nuclear reactors. We won't have fossil fuels. Cars could have fusion cores, and that's gonna be imagine. I love cars. I'm a software engineer, but I also love all types of engineering, and cars are like amazing because imagine if they had a fusion, so much energy with it. They would be so fast. Okay, they would have so much, and you would just put helium in them to power them. It would be amazing. Okay, um, so they wouldn't have any gas emissions, zero emissions. There's no residue, it's like having super powerful nuclear reactor inside your car, but doesn't have any dangers of blowing up or having nuclear fallout reactions or residue. It's gonna be amazing. Okay, so we're very close. We're very close. But there are two main things that I see are about to that are impeding us. Okay, there are two major obstacles. Okay, one technical, one technical, which I mean by that is a scientific challenge. Okay, uh, and a second one that is uh, political. Let's say political, and I'm gonna talk about that. Let's first talk about the challenge of the technical challenge, scientific challenge. Okay, the problem is when we our first step will be to go to Mars, and to Mars is gonna be an example of us habitizing a planet, and that's gonna be key to be able to make habitats of other planets throughout the solar system, right? But the main challenge for us to terraform Mars is that even when we melt the ice caps and the sun starts vaporizing the water like it does in our oceans, creating clouds, which then blocks sunlight and then creates a greenhouse effect, right? Which then warms up the planet. Mars is a very cold planet. Okay, it has to warm it up as well, and it creates so the atmosphere will still be 7% the pressure of Earth. Okay, so Earth has pressure. It has a lot of weight in air, which is a combination of all types of gases, right? above our heads, okay, all the way up to the end of the atmosphere. There is all that weight. Air has weight, it has mass, it has substance, even though it's all around us, we cannot see it. But just like when you go deep underneath the water, all that water, all the weight of the water above you is it generating pressure on you, okay, making molecules come closer and closer together. So does the Earth's atmosphere. So does the gases that are above our heads, right? They put weight on the surface and everyone in it, and that's what keeps us together. That's why if your spacesuit like gets punctured, right, and it loses all its pressure, it depressurizes, okay, you're gonna have a real big problem because your blood vessels is gonna have a hard time staying inside your body. Okay, your lower density materials, water, blood, it's gonna have it's not gonna be good. Okay, and so it's very important, not just all the being able to have breathable air, have water, have plants, but also the pressure. And with all the terraforming combined sources, we only get 7% of the Earth like atmospheric pressure, meaning that we could do all this but still not live without a spacesuit outside Mars, in the atmosphere of Mars. They're still working that out, but that's the major challenge, the major technical challenge to terraforming Mars. They still have to come, scientists still have to come up with a new technology that allows them to pressurize the atmosphere of Mars, besides the technology that they want to use to uh, melt the ice caps, which is, by the way, solar mirrors. They're gonna use mirrors to reflect sunlight, like a magnifying glass, like a kid with a magnifying glass trying to light leaf on fire. Like they don't try it at home, guys. Don't. This is not me condoning it. Okay, don't do it. Don't do it at home. But yes, it's the same concept where you focus sunlight into a specific point to create a concentration of energy, which then is heat. It manifests as heat, and then melts the polar ice caps, creating a constant chain that creates liquid water and sustains it. And then the whole raising the temperature will keep that water liquid. It's a whole process, but it's possible. The only thing they haven't, well, I'm sure there's more things, but the main thing that they haven't figured out is how to pressurize the atmosphere. Now let's talk about the political challenge, okay, to the whole future, not just for terraforming Mars, the whole future of space, okay. And the re- the real the reality is, think about space as the new frontier, right? A lot of people call it that. And that's a reference to the old Western civilization, where they had a boundary, right? They had a boundary, and everything else was foreign. And as people moved outside into the wilderness, they were able to claim territory, claim land, and say, this belongs to X or Y or Z nation. Okay, so the new frontier, refers to that conquering of the wilderness. So now, right now, pretty much all of Earth has been claimed, but the space has yet to be. Okay, so there are planets. I mean, planets. There are countries, okay, that have agreed and have signed what's called the Outer Space Treaty, or yes, the Outer Space Treaty here. Um, this was signed on 1962, 1963. So it's pretty old. It's pretty much as soon as we started going to space and we saw that we needed to, this was going to be a thing. So what it does, it makes so these three major countries, Russia, the UK, and the United States, have agreed that the and I'm sure others, but these were the major space programs, space active nations at the time. Okay, so that's why they're highlighted, but I'm sure there are more. But it says that the exploration, okay, I'm just going to read. The exploration and use of outer space shall be carried out for the benefit and in the interest of all countries, and shall be the province of all mankind, meaning no one country can say the moon is mine, the moon belongs to US, the moon belongs to Russia, the moon belongs to China. Okay, no, the people that signed, the countries that signed this treaty agreed that they wouldn't claim space for themselves. Okay, that's very important because there are countries that have not agreed to this. Okay, the most dangerous, most important one to note is China. Okay, the Chinese Communist Party, okay, is racing to space. It's very like close. Okay, they have because they can claim if they settle on Mars, if they settle on the moon, they could threaten us with violence. Okay, if we start landing on the moon after they have claimed it, they have not agreed to any treaty as of this sort. All right, and if we look, okay, China, the Chinese Communist Party, and their space programs have been incredibly damaging. Okay, to the future of the space programs, our present space programs. I'm just gonna mention two recent incidents that happened that put all the efforts of the ISS in danger. Okay, the first I'm gonna mention is here. There was an instance. Okay, this went wrong. I'm just gonna refresh the screen. There was an instance where the space station, the International Space Station, this doesn't belong to any one country. It belongs to the organization. To I'm not even sure. Okay, but it doesn't belong to any one country. But it's a combined effort. Okay, of all scientists, which is amazing. It's us coming together as humanity. Okay, to achieve a mutual goal. But no, China puts that goal in jeopardy. Okay, with debris. They they're very responsible with their launches. Okay, and with their space projects. They leave debris and in random trajectories without any plans of recovery. And this debris, which is it's just bolts, pieces of satellites. Um, Things that were left, and they're sometimes very small, very for example just a small a screw that impacts the space station can perforate the surface of the where the spacemen live. Okay, imagine the same effect of depressurizing your suit but on the entire international space, and it's going to be catastrophic. Okay, it could damage components that are going to be very difficult to repair, or could even be life threatening to the people that are in this space in this space station. Not to mention the fact that their neglect could cause political conflicts down on Earth. All right, because that's where I'm heading with the next article. Okay, but yes, the space station, the International Space Station, had to use their propellers. Luckily, they have this ability to, with their solar panels, use energy to release air or compressed. And I'm not sure how that technology works, but they use the same propellers that we saw or we talked about to move the spaceship, and they were able to dodge it. Okay, they were able to dodge it and save the International Space Station. Imagine if this International Space Station would have been damaged and destroyed. Okay, it could have lost orbit. It could have fallen out of orbit if their systems, okay, are compromised. They might lose orbit, and if they lose orbit, they're gonna crash down to Earth, and that could be a very very tragic situation. Okay, so this is not the first, and I'm sure it's not gonna be the last. But this is something that we have to be aware and be able to stand up and say, like, no, we have to be responsible with space as we are responsible with our environment down on the Earth. Okay, next, The second article I'm gonna show you is gonna this one is even to me it makes me even madder. Okay, okay. China launches a rocket. Okay, and their first stage is orbiting space for days. Okay, as per mission, but instead of recuperating the instead of recuperating the leftovers or disposing of them safely, they just literally randomly let them fall back into Earth. Okay, this has been a strategy for some types of satellites and vessels which are small enough to decompose by the friction of the atmosphere. They light on fire and they decompose like a meteorite that never reaches the Earth because it's so small that it vaporizes in the atmosphere. Okay, but these are huge, massive chunks of rocket and metal, okay, that are one single piece, and they don't burn up, they don't disintegrate on their way down, so they actually make contact with the ground. This one that just happened this year, 12th of May 2020, it landed in the ocean of Mauritania, okay? But the trajectory was so broad that it could have easily landed in New York City. Imagine, imagine the devastation. Imagine the political conflicts that would have arisen because of that impact, okay? It would it almost seems deliberate that they like it makes me really angry because this is the true obstacle. It's not the science, it's not the energy, it's not the technology, the effort, the human effort, the human capability. Okay, we're almost able to terraform Mars. That's amazing. We're almost able to create compact fusion cores. Amazing. But China is putting all that in jeopardy. We all know the dangers of a nuclear conflict, a conflict between two nuclear powered nations, or that have arsenals. There, I believe the CCP is the biggest threat to mankind right now, to all mankind, to peace in the world. Not to mention all the espionage and the control they're trying to exert on our social on our media, our social media, our information infrastructure. Okay, that's a danger. But I just wanted to give you a hope, a message of hope, because we are so close. We are so close to a brilliant future, okay? Without contamination, at least energy contamination. We still have to deal with plastic and other kinds of waste, okay? But it's gonna be really good. We're gonna be able to power technology with fusion here on Earth that will be revolutionary, that we cannot even dream of yet because we don't have enough energy to supply it, to make it feasible. Okay? Um, so, and it's going to make energy so inexpensive, raising so many people out of poverty. This amazing. Okay? We are so close. We have to unite. We have to be peaceful. We have to work together, okay, for this bright future that's ahead of us, okay, and it's so close. This is our inheritance. We have inherited all this technology from our forefathers, and we're going to pass it down to our children. Let's 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 make it so, okay. But let's say, okay, everyone notice who is impeding this dream from achieving, and let's say no. Okay, let's say enough. Okay, if you want to be in space, you got to be responsible. You cannot put the lives of people down on Earth on jeopardy. If we don't get to Mars, okay, many people talk. I forgot to mention an extinction level event is the other reason why we have to leave our planet. Okay, it is only a matter of time, whether it's trillions of years or it's 50 years from now. We never know. Okay, there might be an asteroid that's on the right trajectory, that or a comet, even comet would be even worse. That's on the right trajectory to impact Earth. We cannot move Earth. Earth is in a constant ellipsis, and it's very predictable. We can go forward in time and we can go backwards in time and see exactly where the Earth is going to be because the speed is a constant. There's no acceleration or deceleration. That means that if already an asteroid is on this way, there is no way to avoid that if those two trajectories intersect at one point in time and space, then we have no way to beat that unless we leave Earth, unless we're already a civilization that has space stations, that has colonized moons, that has colonized Mars, okay, that has maybe even ventured to the outsides of our solar system. Although that's a very big challenge, so don't expect that to happen anytime soon. Um, I can go into that in depth, but they just found things beyond when our Voyager's satellites just crossed a place where the gravity of the sun like creates a difference, and the amount of radiation and stuff that's out there is totally hazardous, and it's very difficult for us to think about leaving our solar system just yet. Okay. But yeah, I'm just gonna say, yeah, stay hopeful, stay like believe in peace, believe in de-escalation, okay? Come together, and our dreams are about to be fulfilled. Everything that we all want, okay? Peace on earth, you know, endless amount of energy, no power, like elimination of poverty, no contamination. It's gonna be amazing. Technology that you cannot even imagine because we're gonna be able to power it, all right, and safely. It's amazing. It's amazing, guys. So if you like this video, don't forget to like, subscribe, hit the notification bell. I want to do more videos like this where I just go and do talks. But otherwise, I'll see you in No Man's Sky, where we get to play and enjoy that space adventure game. But yeah, this is Tony signing out. Hope you enjoy this and see you on the next one.